stem and leaf diagram part of your statistics. Let's see. A company was interested in investigating the fitness of its employees. The table below shows the heart rate of 10 employees measured before and after exercise. Now, even without the stats data, we understand that when we do exercise, what happened? Before the heart rate, our heart doesn't beat as much. When we do exercise, it beats faster. So that's the main idea. The heart rates are measured in the beats per minute. And we can see that for this employee A, let's say Adam, before is 60 and after is 71. So it increased, which reflects life. So what do we need to do with this information? Complete back-to-back stem and leaf plot below to show this information. Two values are already filled in. So how do we fill in stem and leaf diagram? Actually, let's get that slightly lower. Oh, can I get it slightly lower? Let's get it slightly maybe smaller so that we can see the values. Okay, so here that's the stem, and then it grows like a leaf. Starting, it's growing like that, isn't it? Like a leaf. So here I am starting with the smaller number and then getting to the bigger. So when we are looking at 6, that means 60. And 0 means 60, yeah? Then we are saying, okay, so before the exercise, so we're looking at these numbers. We are saying, okay, what other value have 60? We have 68, 67, 65. So we have 3. So 5 will be next. So I have 65. So that's gone. Then I have 67. So I have 7 here. And then 68 is the last value. So that's how the stem and leaf work. Okay, then let's have a look at 70. So we have 76, 77, and 70. So 70 will be the smallest. Then the next one will be 76. And then the last one will be 77. So then we are only left with 80. So we have 89, 83, and 88. So 3 will be the smallest, followed by 8 and then 9. So we have before, and then we do exactly the same for the after. So again, we start with 6. So how many? Oh, we don't have anything in 6. Okay, how about 7? So we have 71, 79, and that's it. We have only 2. So we have 71, then the next one is 79, then 80, 1, 3, and 7. So 1 smallest, then followed by 3 next, and then the last one will be 7, then 90. So 90, 90 we have only 1, 91. Okay, perfect, that's gone. Then we are looking at 100, 102, that will be 1, and 108. So 102, 108. You can see 10 and 2, that 102, 108. And then the last one is 113 and 118. So 13 and 118. Okay, so we have all our values filled in. Let's see what we need to do next. So next part is saying the values of the heart rates after exercise are shown again below. So after the higher values. So we have to work out the mean and standard deviation of the heart rate after exercise. Now, mean, normally, how will we work out mean? Normally, we will add up all these numbers, all of them added up, and then we divide by how many numbers we added, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, by 10, and that's how we get the mean. However, standard deviation is a more complex calculation, so we need to actually know how to use our calculator for statistical calculation in order to get at least standard deviation. Now, everybody have a different calculator. If you are using a version of Casio that is FX 83 GT or 85 GT, then what we do in order to get those values, we go to menu, Majority of them, that's how you get it anyway. Then you're looking for stat. So in case of this calculator, that will be 2 stat. Then we pick one variable because we have only one variable, right? Then we put all these values. We're going to see, at least in that Casio, we're going to see like a table, and we put 71 and then we press equal, and that takes us 81, and we press, and so on. We put all the values in. When we have all the values in, we press AC button, everything disappear, and then we look for the button on our calculator that is saying OPTN, which means option. So when we press that, again we have a list, and from that list we choose 2, and it will be one variable calculation. That's the one we pick. So when we pick 2, we're going to see list of items, and our mean will be X with a dash above that. And if we put our values correctly, we should get 93.3. And then for standard deviation, it's going to be that type of a funny sign with X. And that here, if we put our values correctly, it should be 15.1. But like I'm saying, everybody use different calculators, so you need to know how to use your calculator to find those values. Okay, and then the next part, based on your stem and leaf plot, how has the standard deviation changed following exercise? Give a reason to your answer. Now, this part of question is really tough. So let's say you are in the exam and you are reading this part and you are saying, God, I don't know what they are asking me. So let's see what we can figure it out. So based on the stem and leaf plot, so we are looking at the plot. Okay, we can see that. Okay, so based on that, how has the standard deviation? Now we know we've done the calculation, standard deviation is 15.1 after exercise, because that's the one. How has it changed following exercise? Okay, so I'm saying, what can I say about the change? Because standard deviation means we are deviating, meaning going away from standard. And standard is the mean, is the average. But if we look at the graph, so here we can see that that's how more or less our leaf look like, isn't it? And then on the other side, it has a different shape. So what can you observe? Even like I'm saying, if we don't fully understand how does the standard deviation going to be affected. So we can see here that all the numbers are around the same values. We have in 6, in 7, and in 8, all of them here. However, when we are looking at the other side of the graph, we can see that we have with 7, with 8, with 9, with 10, with 11. That data is what spread more. Okay, so what does that mean? That means for our standard deviation, that means that our standard deviation have increased, have gotten bigger, because we are deviating, meaning going away from the mean in further. That's what I could say. So let me see if I can explain that a little bit differently. So let's think about empirical rule, because that's where we know standard deviation and mean. So mean is in the very middle of the way the data is spread, isn't it? And then standard deviation, if I go away, deviate from the standard, right? If I go once, here I am going to have 68% of all data. Now, let's think, so let me just get it here again. So here, if that is the mean and standard deviation, so let's say the mean is 10 and we are going +2, -2. So we're going to have 8 here and we're going to have 12, isn't it? So that data will be very concentrated around here. Now, let's change that. And we have 10. And let's do our standard deviation 5. That means if I go both direction 5, so here I'm going to have 5. Here I'm going to have 15. Do you see how the data spread? Here is very, very close, and here it spread more. Because here the standard deviation, oh, sorry, that's -5, +5, because here the standard deviation was smaller in value, and here was bigger. Therefore, the spread of the data is bigger than it was here. Here, it's more kind of concentrated, taller, and here it's kind of spreaded, yeah? So that's the idea. That's what the question is asking. However, it is extremely difficult concept to grasp. What I am saying, if you are in the exam and you are having a difficulty, have a look at a stem and leaf diagram, because that's what they are saying, and tell them what you observe. And tell them you observe that here they are all close to each other, they are in the cluster, while here they are more spread. And actually you are giving the true statement there.